Right. So welcome back, students. In the previous video, what did we see? We have seen what actually is a combination reaction. We have also seen different examples of combination reaction, and we have also watched an animated video, that is NCERT activity 1.4. Now today we'll be studying about the type of the reaction, that is nothing but decomposition reactions. So decomposition reaction, again, if I have to say decomposition reaction, RXN is reaction which I have written. So decompose, that means composing is what? Suppose this is a duster. This is a composed form together as one entity. Now if I apply any heat, if I apply any light, or if I apply any electricity, I try to break it into pieces, correct? So compose means one quantity, decompose means breaking into number. Now in decomposition reaction, as I say, it is nothing but it is the breaking down of one compound, means one particular substance, into two or more elements is called decomposition reaction. Let us define that once again. Decomposition reactions are those reactions in which one compound decomposes into two or more substances. I think you have written that. Shall we write the definition? Yes. Decomposition reactions are those reactions, I'm not writing the full sentences, are the reactions in which, what did we say? In which one compound or one substance, let us write one compound, because compound is a combination of two elements together, two atoms together combined to form a compound. So one compound decomposes. So after writing decomposes, I am going to write a word in the bracket, that is a general word, that is breaking. Okay, right. One more word of breaking, dissociating means separating. So those reactions in which one compound decomposes or breaking out or dissociating into how many? Two or more substances. It can be more substances. It can be three also, right? Now here let us take an example. So I think you have noted this. So most important in the exam, first you need to write the definition. After that, this is a general form. Whenever you are writing the general form, put it in a box like this so that the teacher will understand, okay, that you have understood that. Now I'll be giving examples of different decomposition reactions. Let us first list out. Here in decomposition reaction, I'll be teaching the decomposition of first one, calcium carbonate. I'll be giving this as an example how it's dissociating. Now isn't it one compound? Calcium one atom, carbonate is one. Done. I'll be teaching the decomposition of ferrous sulfate. So ferrous sulfate is what you have in your NCERT. There is an activity 1.5 which I'll be showing it in an animated video at the end of this. So please watch that. Right. After ferrous sulfate decomposition, I'll be teaching the decomposition of lead nitrate, PbNO3 taken twice. I'll also be showing you the decomposition of potassium chlorate, potassium formula KClO3. I'll be teaching all this. Now what is special in this? So all these compounds, they'll be decomposing in the presence of heat. What is this delta? Delta means heat, right? So here one more thing is there. Heat is one, sunlight is one, bulb, the light in the form of a bulb is one, electricity is one, but all are used to decompose only, break into pieces. Now I'm going to use heat. Here also I'm going to use heat. Here also I'm going to use heat. Here also I'm going to use heat. Now heat in the lab, what we do, we take all these in one test tube and take it in the boiling test tube and put it in the Bunsen burner. So that heat is nothing but the Bunsen burner, right? Next, after this decomposition, I'll be teaching the next type of decomposition, that is decomposition in the presence of sunlight. This is heat. Now I'm saying sunlight. So I'm going to teach you the decomposition of silver chloride, that is in the presence of sunlight. I'll write it as sunlight. I'll also be teaching you the decomposition of silver bromide, where These two reactions will occur in the presence of sunlight only. So these reactions will be used for black and white photography. That also I'll teach that. Right. After that, I'll be teaching the decomposition of one more type, that is electrolytic decomposition. Electrolytic decomposition. So in electrolytic decomposition, electrolysis. Electro means electricity. Lytic means breaking down. So I'll be lysing it using electricity. Which example I'll be taking? I'll be breaking out water molecule using electricity or electrolysis. So what is this process called? Electrolysis. So here what did I do? Here let me write that electrolysis. Here what did I do? I have written delta. So again, once again, let us write thermal decomposition. Delta represents heating. Under which one? Heating under Bunsen burner, which you use it in the lab or the spirit lamp. Next. Shall I write that? Okay. Heating under Bunsen burner. Okay. This is fine. After that, what does that sunlight mean? So sunlight, it is in the presence of outside. You'll take silver chloride or silver bromide in a china dish and expose it to sunlight. So that is that decomposition with sunlight. Next, electrolysis. Electrolysis means I'll be using electricity for breaking that. So shall we start with the example, students? But ma'am, what should I remember in this? Important. Here you should remember the products which are formed, point number 1. Second thing, you should also remember the color from which it is getting converted. Suppose ferrous sulfate, initially the color of the crystal is green, then it will become white, then it will become brown. So those colors they will ask in the exam. So let us take in detail. Let us go slowly but understand. So I think it is clear. Now decomposition reaction means a compound or a substance breaking into two or more substances. Now let's start with the examples. Right. Now, after understanding the concept of decomposition reaction, what did we say? One compound breaking into two or more. Now, we'll see the examples. You'll have a better understanding. Right. So, here in examples, let me take first two examples and then explain you the next two example. Right. Here, basically, I said I'm going to take an example of what is this? This is called calcium carbonate. Let us write the name calcium carbonate. Okay. So, why carbonate? Carbonate is a polyatomic ion. So carbonate is one entity. Don't say calcium 1, carbon 1, oxygen 1. No. Carbonate is only one entity here. Done. So what is the other, this one, after this procedure, you're going to take calcium carbonate in a boiling test tube and you're going to heat strongly. When you heat strongly, it dissociates, that is compound AB dissociates on heating into two, that is calcium oxide plus carbon dioxide, which is evolved in the form of a gas. So up arrow, right? So calcium carbonate, how did we divide? Basically it is something like this: CaC, O1, O2, O3, 3 are there. So the first one comes out as calcium oxide, calcium positive charge, oxygen negative charge. So plus 2 minus 2, we get this. The leftover comes out as carbon dioxide. So CO2. Done, isn't it? Now let us write here. AB is broken up into A plus B. What is the name of calcium oxide? It is nothing but quicklime, isn't it? Quicklime. What is this? This is nothing but carbon dioxide. So here what is happening? Remember, because of this heat, that is a thermal decomposition we call, isn't it? So because heat is provided here, we write this type of reaction as thermal decomposition reaction. Now why did I write this? Because in your exam they may ask you, give an example of a thermal decomposition reaction, or they may give you 4 different reactions and they'll ask you among the following which is the thermal decomposition reaction. So whenever you see delta on the top of the reaction, it means it is thermal decomposition reaction. Here, you know, during this, there's lot amount of heat which is released. That's why the process immediately it breaks down. Now further what they do, now this is decomposition, I understand. Now further calcium oxide they take, mix it with water, and then they form lime water. That also I'll explain in the next example. Don't worry. Now this is clear, I think. So we have taken one first example, decomposition, that is thermal decomposition of calcium carbonate. Right. Now we are going to take one more example. Now what is the color of this? It is white in color. Calcium carbonate is white in color. Right. Next example which I'll be taking is ferrous sulfate, FeSO4. Now basically ferrous sulfate is a crystal. Okay, right. So crystal means, now you see in your house you have salt crystals, no? When you hold it, it will be rough in texture. So ferrous sulfate is a crystal. The formula of ferrous sulfate is .7H2O. Now what is this 7H2O, ma'am? Just see, every crystal, suppose, let us see, when you touch that, after some time, like, you know, you feel it, they are dry. I'm not denying that. But basically the color of that crystal, whether it is white, blue, green, and different colors, are only because of this compound, that is water of crystallization. This part is called water of crystallization. Now what is the role of water of crystallization? Just now I said they impart color to the crystal. So they give color to this crystal. Now because now all will have 7H2O? No. Some will have half H2O, some will have 5H2O, some will have 2H2O, like that. It will vary with different crystals. Now because of this 7H2O water of crystallization, the color of, let us write this water of crystallization here so that I have space. So this is nothing but water of crystallization. What does it do? It gives color. Let us write that also for your note. Listen, it imparts color to the crystal. It gives color to the crystal. Done. Now this 7H2O, what is the color of this crystal? Very nice green color you'll have, like, you know, blue and green mixed together, right? So what happens, I'm going to take this crystal 7H2O, ferrous sulfate 7H2O, and I'm going to take delta. What is delta again? I said you're going to take the crystal salt in a boiling test tube and heat it under the Bunsen burner. So you will take this, let us assume this is a boiling test tube. You will take a pair of tongs, you know, no, to hold the test tube. Without that, never heat it directly. You will hold the tongs and put it slanting in this way. One thing you need to remember, whenever you're heating in the lab, you should hold with the tongs. Important. Next thing, you should hold the test tube which you are boiling in a direction where there is nobody. I have seen lot of students, here you will be heating, your friend will be standing in front of the test tube. The gases, or if any acid spills on the face, you should be very careful, students. Remember, always remember, test tube should be kept in a position opposite to your this one, or where there is nobody. Careful. When you heat this ferrous sulfate crystal 7H2O, immediately what happens is, first thing, this water of crystallization is lost. It will get evaporated, means it will come out of the test tube, it will get evaporated. What is left out if I take out? I have ferrous sulfate only. Now here, ma'am, what is the name of this compound? You didn't write. Yes, I didn't write. Now I'll write. What is this? This is ferrous sulfate. Okay, ferrous sulfate. What is this number? 7. 7 means hepta or septa. No problem. So septa or hepta, water is called hydrate. So what is this called? Ferrous sulfate hepta hydrate. Over. Now do you have any water of crystallization here? No, it has evaporated. The name of this compound is called anhydrous ferrous sulfate. What is it called? Anhydrous ferrous sulfate. Okay, this is also clear. Ma'am, what is the color of this now? Anhydrous, always remember, whenever water of crystallization evaporates, immediately the green color here, green will get converted to white crystal. So green will become white crystal. Now further I am heating it. When you are heating further, delta, this FeSO4 gets converted to Fe2O3. This is the procedure. Now what is the name of this compound? Fe2O3. This is called ferric oxide. ferric oxide. Now, along with this, you will have two more gases which are released. From where they are releasing? Because this is ferrous sulfate, isn't it? Sulfate means there are two varieties of gases which are released. That is sulfur dioxide and sulfur trioxide gases. Sulfur dioxide and sulfur trioxide gases both will come out of the test tube. Ma'am, what is the color of this? You didn't say that. First was green, next was white. The last one is a brown powder. You will be getting a brown powder in the test tube. So what is happening? The decomposition reaction, crystal green in color got converted into crystal white in color, got converted into powder which is brown in color. So along with that, one compound has decomposed into 1, 2, 3. I said, isn't it? Decomposition means breaking down of one compound into two or more substances. Correct? Now let us come and meet with two more examples of the thermal decomposition. Right. Now let us come back and see two more examples of decomposition reaction. Right. So here in the last what examples we have seen? We have seen the thermal decomposition of calcium carbonate, thermal decomposition of ferrous sulfate. So in calcium, whenever carbonate dissociates, you get carbon dioxide gas. Whenever sulfate dissociates, you get SO2 gas, and SO3 also we have written. Now we are going to see two more examples, that is decomposition of, again, thermal decomposition. So let me write that here. I am going to give you thermal means, I said heat. In the lab you will be heating under Bunsen burner. So thermal decomposition. So thermal decomposition of lead nitrate, PbNO3 taken twice. It's a solid, right? I'll be also giving you the example of thermal decomposition of potassium chlorate, right? Now here lead nitrate, whatever is there, again I'm saying, whenever you see carbonate means carbon dioxide evolution, sulfate means sulfur dioxide evolution, nitrate means NO2 gas. Remember this. If you remember, it's easy to write the product. Done. Here I said, now oxygen means, O3 means oxygen comes out. Lead nitrate is a colorless solid. Okay. Now when you're heating, it decomposes into three different compounds. What are they? It's going to form lead oxide, one compound. Nitrogen gas comes out of this. Along with that, oxygen also comes out as a gas. Done. Here this lead oxide, so this is lead nitrate, this is lead oxide. Let us write the names. You need to write in the exam everything. Name should be written, color also should be written, very important. Now this is called lead oxide. The color of this lead oxide, there are two different colors of lead oxide. When it is hot, the lead oxide is hot, the color is almost reddish brown. Okay, lead oxide is reddish brown if it is hot in color. Suppose if it is cold, means it is cold, it has become, the temperatures come down, then the lead oxide solid will become yellow in color. So in the exam they will ask, name the compound which is reddish brown when hot, yellow when cold. So that is nothing but lead oxide, right? So here again you have nitrogen dioxide gas, where brown fumes, reddish brown fumes, they come out of the test tube. So are you not finding the dissociation? What have you observed? One compound dissociating into two or more. Important. Earlier we have seen carbon dioxide and sulfur dioxide gas. Here we are seeing nitrogen dioxide gas. So here the color changes from colorless to, when it is hot, reddish brown, colorless to, when it is cold, it is yellow in color, and nitrogen dioxide gas color is reddish brown fumes or brown fumes. Done. When I see KClO3 dissociation, again thermal decomposition, it breaks up into KCl plus oxygen. Here I am not balancing anywhere, because I did balancing. You need to check the earlier video and balance by yourself. So here again oxygen gas is evolved. See, one compound is dissociating into two or more compounds. One compound is dissociating into, AB is dissociating into 2 or more compounds. So isn't it simple? So decomposition by heat is over. Now we are going to see the decomposition in the presence of sunlight. Let's come and see those reactions. Right, students, so in the previous video, what did we watch? We have seen the thermal decomposition reaction, isn't it? Now we'll be seeing the decomposition reaction using sunlight. So let us once recollect what have we studied. So decomposition, we have said the definition. Then we said there are 3 varieties of decomposition, that is thermal. That thermal can be heat, where we are using it or you doing it in the lab. Next would be using, the sunlight. Right? It can also be used using a bulb also. So heat you are generating and you're making the reaction or allowing the particular compound to break into 2 or more substances. Now again one more, the third variety is you will be using electricity. And what did I say? What is the name of the process called? It is called electrolysis, correct? Yeah. Now so let us take the second example, decomposition using sunlight. Or right. So here we'll be studying decomposition using sunlight. So basically for your grade 10th you have 2 varieties of reactions. Simple, let us write that. So you have decomposition of silver chloride. So here we'll be learning what will happen when I decompose silver chloride using sunlight. Next, there is also decomposition of silver bromide. NCERT has not given this reaction, but we will not leave that. We will write that reaction also. Right. So when I say silver chloride, silver symbol is what? It's nothing but Ag. So chloride is Cl. I already said in grade 9 you have studied the formulas of how to make using crisscross method. Don't worry, I'll be doing a video how to write the formula also. Right. So here silver chloride is a solid. What is the color of silver chloride? Basically it is white in color. White. So it's a white solid powder. What we are going to do, we are going to take this silver chloride in a china dish, okay, or a watch glass also. And what did I say? The condition is here it should be exposed or kept in sunlight. So sunlight we are going to keep it and expose. When it is exposed for 4 to 5 hours, what happens? Silver chloride is going to decompose into 2 different products. One would be silver and one would be chlorine gas. One is the chlorine gas, one is the silver. Now the silver which is formed here, chlorine is 2. So I'll put 2 here because now silver has become 2. I'll also put 2 here. We have already studied the balancing of reactions, isn't it? Right. Now what is happening when you are taking the silver chloride and you're keeping it or exposing it to the sunlight for longer time, the white color silver chloride, it gets decomposed into a grayish color powder. Grayish white means it will become the little bit, what is gray color, isn't it? So it will turn from white, pure white, to a grayish color tinge. You can observe it. So when it turns into the grayish color, I can say that the particular silver chloride has decomposed into two different atoms, right? The same thing if I take silver bromide. So silver bromide, AgBr, again the same thing. What condition? You should say sunlight. So in the sunlight, it's going to again break up into 2 different atoms. One would be silver, that is the same, and the other is a bromine gas which is evolved. Okay, so gas means I have to write this, isn't it? Yes. Now silver bromide, what is the color of silver bromide? It is basically yellow in color. Okay, a pale yellow in color. Let us say pale, right? So pale yellow in color, right? When it breaks or when it dissociates, again it forms silver. Now what is the color of silver here? Grayish white. So here also it will be grayish white. So what here again, let us balance. Bromine is 2, so I'll put 2 here because silver is 2. I need to justify law of conservation of masses, so I have written that 2 there. So here what is happening in the exam? What are they going to ask you? They're going to ask you, say, what is the white color substance or the grayish white color substance which is formed due to thermal decomposition? You need to say it is nothing but silver, right? Next question, what is the they'll give you a compound A, which is pale yellow in color. When exposed to sunlight, is going to get dissociated and get converted to grayish white solid substance. What is that? It is nothing but silver bromide. So what actually is the concept? You need to remember that when I use light, when I use sunlight, or when I use electricity, I am trying to decompose it into two or more compounds. That is a concept. What are they going to ask you? They're going to ask you colors. So you need to remember the colors. Right. Now, here one important thing. This particular reaction, both the reactions rather, are used in black and white photography. So here they'll be also asking you, okay, this is used in black and white photography. Black and white photography. Right. So here nobody will ask you what is how it is used, black and white photography, what it is, but I'll give you a small idea about that black and white photography. What happens is, here silver is a metal, right? It will be giving electrons to chlorine. Again chlorine, from chlorine one electron gets excited, so silver captures that electron and it will form a, means when you allow it to get exposed to the sunlight, it will capture that electron and it forms a coating on that particular film. So I'm giving you just an idea, but remember, if you're really interested, the lot of websites where you can see, I just gave you the basic concept. Capture of electron and going to the excited state and forming a coating is what is black and white photography. So nothing, I've just given you an idea. More interested, you can watch. So this is the concept of decomposition of silver chloride and silver bromide. Remember the colors. I'll get back to you again with electrolysis process, that is the decomposition using electricity. Right. Now, let us come and finish off the last part of the decomposition reaction. That's nothing but decomposition using electricity. So, what is the name given? That is nothing but electrolysis. So, what is it? Electrolysis. So, as the name suggests, electro means electricity. Let us write that. So, this is nothing but your electricity. Lysis is nothing but cleavage or breaking into smaller parts. Breaking into lysing, small. Say you take a paper, you tear it into small pieces. No, that's nothing but lysis. Right. So, here what examples we are going to take and what do you have for your NCERT? So, basically electrolysis process, I've done an animated video for this. Very nicely I've shown you what is an electrolytic cell, what is the role of sulfuric acid and everything. But I'll just explain you the examples here. Please go and watch the animated video which is there at the end of this video. So very nicely you will understand, you'll not forget also. Right. So in electrolysis process, basically if I have to take water, right, what am I going to do? I'm also going to take one more, that is sodium chloride. Nothing, students, it's simple. So what we're going to do, you're going to take a beaker. As I said, I'll explain in animated video. Our final concept is one compound has to decompose into two or more compounds, right? Here I'll be using electricity. I'll be connecting to two electrodes. I'll be using sulfuric acid also in the particular cell. I'll be taking two electrodes, that is anode and cathode. I'll supply 6 volts. I'll arrange 6 volt battery. Everything nicely you will understand. But in the exam, this reaction is not there in NCERT. You need to remember, because the examiner will ask you this. Remember. So water, when you allow it to undergo electrolysis or you'll supply electricity, it breaks up into two. One is hydrogen gas and oxygen gas. Remember this. Now, hydrogen gas goes to one electrode, oxygen gas goes to one more electrode, and the bubbles you can observe in the experiment. What is next important? How can you test hydrogen? Remember, what you do is you get a candle near this. We have studied in this one earlier also, isn't it? So that okay, maybe next chapter you will be studying, that is reaction of acid plus metal. Let us see. when to test whether the hydrogen bubbles have come out or not, what you do, you take a candle and you go and put that candle near the mouth of the this test tube or the electrolytic cell, wherever bubbles are coming. So you can watch the video. So always remember, hydrogen gas is tested, or we can say that hydrogen gas is evolved when, that is, when you take a candle, whatever means lit candle, means the candle you need to and just light it, and the candle, it will start burning with a pop-up sound. So whenever in your exam, whenever you see pop-up sound or pop sound, nothing, the examiner is talking to you about hydrogen gas only. So the hydrogen gas can be tested using burning candle. Point number 1, when the burning candle is brought near hydrogen gas, immediately the gas and the burning candle, immediately the flame starts giving pop sound. You can go to different pop sound, popcorn sound, how you get that way, the pop sound, right? So that is the indication for hydrogen. Now very well know oxygen gas. What is the indication? Normally oxygen is used in this whole world, oxygen is used to combust. That is what, isn't it? So it will allow, or that particular candle, whatever you're using, you can light that. So ignition. So by ignition, by igniting it, you can say that oxygen is evolved. So please go watch the electrolysis procedure, and other than the procedure, this is what they're going to ask you. Let us come back. Now in NaCl, same thing, I'm going to supply electricity to this. So when you supply electricity, there is a cleavage of the bond exactly in the center. One would be the cation, Na+, one would be an anion. So what is the new symbol I have written? Plus means cation. So remember, metals always form cations because they donate electrons. This is an anion, non-metals. So here cation is one ion which is released, which goes to the opposite electrode. Anion is one more which goes to the opposite electrode. So basically, what is the concept now? Again, one compound decomposing into two or more. One compound decomposing into two or more ions. So let it be thermal decomposition, let it be decomposition by sunlight, let it be electrolytic decomposition. Concept is one breaking into two or more substances. So what is the conclusion? You need to remember, AB breaks up into A plus B is the concept. Nothing. Okay, let us see the animated video now. I think immediately please send your comments. So let us meet again in the next video. Important, I'll be meeting with the next important reaction, that is displacement reaction.
Thank you.